This is an example using double angle formula. If sine 2a is 3/5, find two values for tan a between 0 and 90 degrees. We want to first express sine 2a somehow in terms of tan a. We see that there's a formula that looks like this. There's a formula that says sine 2a is equal to 2 tan a divided by 1 plus tan squared a. This is found in the formulas and tables book. So this is the formula that we'll use. So let's write it down here. Now if sine 2a is equal to 3/5, it must also be true then that 2 tan a divided by 1 minus tan squared a must also be equal to 3/5. And this is the equation that we're going to now solve. With any equation with fractions in it, a good approach is to multiply both sides by the lowest common denominator. So both sides are multiplied by 1 plus tan squared a and 5. When we do this, it looks like this. Now, multiplying the left hand side by the 5 and expanding the right hand side by the 3. What we have here is actually a quadratic equation. We'll write the tan squared term first. So we have 3 tan squared. We'll subtract 10 tan a from both sides. And we have a plus 3. And that it all equals 0. So we have a quadratic equation to solve. It might be easier to solve this if we do a substitution. You could solve it as it is if you wish. It might be easier to see it if you let tan of a equal to x. So what we have here is 3x squared minus 10x plus 3 is equal to 0. So we'll factorize this expression to solve it. So we see that the factors that work are going to be 3x minus 1 and x minus 3. So this gives us two solutions for x. So if 3x minus 1 was equal to 0, we'd have 3x is equal to 1 and x is equal to 1/3. The other solution, if x minus 3 was equal to 0, we'd see that x is equal to 3. And we have two solutions, but it's not x that we want, it's tan a. So just write these out clearly in terms of tan a. So we're saying our two values for tan a are 1/3 and 3.